So now to apply the exact Bayes as a classification method. So here is a small data set. It has only 10 observations. Okay, and we have two predictors and a target. Okay. And the target here is a financial reporting of these companies. There are 10 companies. Okay. So we want to predict, we want to classify the financial reports as either truthful or not truthful. Okay. So our target is status. So F is fraudulent and T is equal to truthful. And we have two predictors. Okay, so we have the first predictor is company size. Okay, and the company size has only two possible values. So L equal to large, S equal to small. Okay, and the second predictor is prior legal trouble. Okay, whether the company has had a history of making false statements. So here prior, so Y equal to, yes, they have had prior problems, N is no. There are only two possible values. So this way, the unique combinations are just 4. There are only 4 possible predictor profiles. So here, so we have L and Y, L and N, or S and Y, and S and N. There are only 4 possible predictor profiles. But in reality, when you have lots of predictors, and within each predictor, lot of possible values, then the number of possible predictor profiles, can be really large, as exponentially increases. That's the reason why exact Bayes method, is impractical as a to be used as a classification method. That's the reason why we have to resort to naive Bayes. Okay. So now we can set up a joint frequency table from which we can compute probabilities. Right? So we will look at that as our data. So we do a pivot table, right? And let's put the pivot table right here, and we're going to have size. Right, and then prior trouble, okay, and status, okay, fraudulent or truthful, as columns, okay, and then we can use any one of these as the values, so that will give us a count under each of those possibilities. Do some formatting. Okay, so now this table, we can use this table for computing probabilities. Okay. So we have predictor profiles. Okay. So what are the predictive profiles? Case 1, will be L and N. Case 2 will be L and Y. Case 3 is S and N. Case 4 is S. Well, let's do it in the same order. S and Y, S and N. Oh no, N first and then Y. It's the same order. I just want to keep it in the same order. Okay. So now we have to set up Bayes model, okay, for each case there will be a Bayes theorem. Okay. So let's take case 1, which is L and N. Okay. All right. Our prior probabilities, okay, for F and T, that's what we need to predict, right? So we have prior probabilities. Okay, let's do P of F and P of T. So that's our prior probability. Prior probability will be you take the entire data set and see what proportion is truthful, what proportion is fraudulent. So that means we are now looking at the entire table. Here is fraudulent, here is truthful. So our probability is C34 divided by E34 will give you prior probability for F, and 1 minus that would be our prior probability for T. Okay? Now we want to revise these probabilities given a particular predictor profile. Suppose if a company comes up, right, and that company falls into the category of large and no prior problems, legal problems. Okay, so then how do you revise this probability to the posterior probability? And the posterior probability will be our propensity, right? And then you can use a cutoff point and then use that cutoff point to compare and make a classification. So prior probabilities are these. So that's the starting point. Now conditional probability, so now this conditional probability is about conditioned on what? Conditioned on the predictor profile. The condition here is predictor profile, okay, which is L and N. So what we want here is probability of L and N given, so these two would be the conditional probabilities that we need are probability of L and N, right? So that is the event that is presenting itself to us. So that given fraudulent and that given truthful. So these are the two probabilities we need, okay, from here. So the first one is given it is fraudulent. So now our sample space has shrunk to just that column. It is fraudulent. Okay. So given fraudulent, we want the probability of L and N. So L and N is that cell, C29. So we have C29 divided by C34. It is given fraudulent, so okay. The same event L and N given T will be D29 D29 divided by D34. Those are the conditional probabilities, right? So now once you have this, the rest is pretty straightforward. Okay, all you have to do is to find the joint probability, which is the product of these two, right? And then you add the two, that will give you the probability of that conditional predictor profile. So this is probability of L and N. Okay, now divide that into that. And you get the posterior probability. So now you will classify that particular predictor profile as truthful with 50% as the threshold point. Okay. So this is how you use exact Bayes methodology for classification.